Hello guys, let's speedrun Heaps. I've done some problems in Heaps. Now we will priority queue, binary heaps, minimum heap, max heap. I'll be coding in Python. Check if an array represents. Wait a minute. What? I think he changed. Oh. Okay. Introduction to Heaps. Just select this. Min and max in Python. How do you do it? Check if any array represents a minimum heap or not. So return true when elements are in increasing order. But each node has a lower or equal value than its children. Lower than children. Lower than children. No, this doesn't have lower than children. Each node has a lower value than its children. What do you mean, man? 10 is lower than all. What about 30? 30 isn't lower than all. True. Okay. 10, 20, 30. 25 is greater. The node with value 20 has a child with value 15. This is not a main heap. But in this case, 10 is lower than everyone above. 20 is lower than everyone above. 30 is not lower than everyone above. Then do they have said true? The fuck is this? The hint is only for. Okay. I'm gonna implement a brute force for this. For in range. For j in range starting from -1 random numbers -1. Okay, and for j in range starting from I+1, so length of nums. If nums of I is greater than is less than nums of j. No, it should be nums of I should be less than nums of j. If nums of I is greater than nums of j, nums of I is what the nums of I is greater than nums of j. Return false. And so I'll return 2. I don't trust this website. What do they mean, man? First question is confusing as fuck. How is this true? Okay. Binary maneuver not written. Binary maneuver is complete binary tree where the key at root is the minimum among all the keys present in the binary tree. So 10 in left, 20 in right, 30, then 21, 23. Okay. 10 in left, right, 20, 30, and then 25, 15. So for every I, left will be okay. For this, left will be this, right will be this. For this will be the left should be this, right? So it will be no, for this this is 0. So 1 is left, 2 is right. Then for this is 21 left, is 23 right. So this is 1 and 2 is 2 plus 1 and 2 plus 2. So I didn't check that it is binary tree. Okay, and for each element left will be 2 into I plus 1 and right will be 2 into I plus 2. This is how they represent. Now left and right should be in bounds. If left is less than n and if here the left should be greater than right, greater than root. Nums of I should be wait left is greater than root. Is it correct? Nums of I should be nums of left should be greater than nums of I. And the other case, then continue, right? And I write the other case. If it is less, then I will straight away return false. Another condition for right is less than n, and if nums of right is less than left is less. If nums of right is 30 is right, nums of right is greater than true, but if it is less than nums of I, return false. Then I return true. Just right. I'll do this. What? Nums of left. Wait, what the fuck? I think this is good. What? If left is less than n is length. सबमिट। वाह भाई वाह, क्या वेबसाइट बनाई है फालतू। Fuck this TOF man. Check if an array is representing minimum heap or not. It should be minimum heap. Convert minimum heap to max heap. Wait, why is this plus? Am I on the wrong sheet? This gets directed to plus. This is not important. Let's go to good lead code problems. Let me check the stream once. Okay, largest element in an array. Probably solved already. Yes, it is. Control X. Also, why is this so small, man? Given an array of nums and an integer k, return the kth largest. Kth largest element in an array, not it is the kth largest element in the sorted order, not in the kth distinctive element. Can you solve it without sorting? So 1, 2. No, largest is 6. Then comes 5. So they're saying don't solve it with sorting. What can I do without sorting? So as the name of title of the video suggests, we should use a heap. What the hell? This was the question. Find kth largest. So first of all, push everything to the max heap. So bigger number will come down. In default, Python has minimum heap. So I push everything to a heap. So we will start with an empty array of min heap, and then we will keep on. So I'll take a min heap, equal to this, and then push everything in that. Phenomenons heap q dot heap push. into main heap nums, and then heapify it, right? Then if so, what will this do? In the end, we'll have the smallest element. This is min heap now. In the end, we'll have smallest element. So in the start, we'll have largest element. So we keep on pushing. After a point, the length will become k. Wait. So let's say in this k is equal to 2. So at any given point, I have to keep only maximum. So I will remove the last element. If length of min heap is greater than k at any point, then I'll do it pop from home min heap, and then in the end, whatever will be at the first position will be my answer. So on the time complexity for this will be so for this it is, for insertion it takes log of what? Log of k. We are removing k times. We are inserting n times, and we are removing anything that is greater than k. So n minus k times. Then what will be that? So for this too, this is of n for iteration, and then pushing takes length of heap. So length of our heap at any time will be k, not get greater than that, so that is log of k. And then removing elements will be log of k n minus k. So it's log of k plus log of k and log of k is the answer. Space complexity is O of k, and let's see what were my previous solutions. Put something here. Only bapre, left pointer, right pointer. What is this? Is this one? Holy. Okay, what is this? Pivot index. Pivot index is our intent. I solved it in Jan 16, and this is way faster than the normal approach. Finding key largest element. This is quick select algorithm, but I don't remember anything. Average case key largest. Let's go to quick select algorithm. Why it is used instead of heaps. Left pointer, right pointer, 0 and -1. Okay. And then pivot index, we are choosing a random index. So I do the full range of an array. And randomly pick a pivot pointer helps to avoid worst case behavior, like when array is already sorted. Then new pivot index is equal to. Then once I choose it, one new pivot index will be cell partition, norms, left, right, and pivot index. So based on that, my cell partition will do something and give me the new pivot index. Partition the array such that elements less than pivot are on the left and elements greater than pivot are on the right. If is this using quicksort? Something. If new pivot index is equal to length of now minus k. Oh, so if we have found that k is correctly placed, now return it. So what we are doing here is we are not trying to arrange all the elements. Okay. If new pivot index is equal to num7, get return num7. This means that we found a kth largest element. Otherwise, if new pivot index is greater than this, then right will be new pivot index -1, and left will be new pivot index. So the right part of the array. Yeah, that I understood. Partition logic. Wait, we did it twice. So based on the given self partition, we get a pivot index, and if this pivot index, whatever we gave, is correct, then we'll return. If this is greater than, that means if pivot index on the right side of this, if it is on the right side of this, then that will become left. No, wait. Greater than, yeah. So if new pivot index is on the right side, then obviously, you know that, right, it will end at a new pivot -1, and its left will be new index +1. Yeah, this I understood. While true. And then the partition thing. Thumbs left, right, and then we have pivot index. Okay. So in order to find the correct position of that, what we do, nums of pivot comma nums of right is equal to nums of right comma, okay, interchanging pivot index and right. Stored index is equal to left. Yo, let's understand the logic for partitioning. Pivot is equal to nums pivot index. It is storing the pivot value. If that pivot value, okay, moving pivot to the end for now, then stored index is equal to left. fine range left to right. If nums of I is less than pivot, then we are interchanging the leftmost nums of whatever is on nums of life I to with the leftmost thing. So we know it is less than pivot, so I'll put it on the left. I'll put the left there. And stored index plus equal to 1. Then, so one of the element is done. I'll move to the next element. And then I'll keep on doing this from left to the right. If it is not, and then in the end what we are doing is nums of right is equal to nums of stored index. What was in nums of right? Nums of stored index. Return stored index in the final position. Each partition reduces the search space in roughly half. Okay, this is like quick sort, but only recurses on one side. Time complexity is off and on average. Worst case time complexity, if pure power chooses every time, it degenerates the linear search scan. Off and on average. So random pivot helps to avoid worst case space complexity. In place partitioning, no extra space, just a few pointers. So space complexity is 1. Let me know if you want to visualize how this works in an example. Yes, sir. Let's walk you through the diagram of finding kth largest function using quick select. So k is equal to 2. So looking for the element at index 6, that is index 4, sorry, this is the index 4 now. After sorting, what will come in this? So left and right will be 3, 4, and then what I do is I'll choose a random index. So let's say our random index is this. So now I'll put this 5 at the end, put this 4 at the start here. Okay, then I will start checking from here to here. Is 3 less than 5? Yes, then nothing. Is 2 less than 5? Yes, then nothing. Is 1 less than 5? Yes, then nothing. Where did we search from? Left to right. Yeah, everyone less than 5 are correct, right? So everyone on the left. But why are we running it till? What was the code? Stored index is equal to left to right. If nums of I is less than pivot, then nums of I and the stored index bro, what? Yeah, right, left 0, right 5, pivot index randomly. Okay, so they pick first index, no, they pick third index, 0, 1, 2, 3, they picked up 5. Pivot is equal to 5. Okay, then move pivot to the end, and they put 5 to the end, 4 came here. Okay, yeah, I got it. And then if 3 is less than 5, swap with index 0. Oh, whom were we swapping with? Nums of I will be swapped with stored index. We are increasing stored index to now. So with stored index 3, no change. And if it is greater, then I don't care. I'm just sorting the left part. Now swap 5 pivot back to correct spot at index 4. 1, 2, 3, 4. So it will come at 4. Write in the return. Then what we check? After it returns some index. It returns stored index, yes. If new index is equal to length of norms minus k. पहले इसमें आ गया तो return norms. Okay. It's too much to remember. Also while true loop, so it will keep on going. At some point I'll find the index. Okay. So I implement this as a practice. I'll implement this after some time. Right, we are solving heaps, don't forget. K small element in an array, use priority queue. Who are you to tell me? K smallest element in an array, smallest is there. Problem lead code. K smallest instruction. K small element in BST. K small element in sorted matrix. K smallest product. K smallest element. Oh wait, it's not there. Sort K sorted sort K sorted array. Let's do the resource for K smallest element in an array. Let's just go to import heap q for the smallest kth element. Okay. Taking a heap and then length of array for I in range. Heap q dot heap push into priority queue negative value of array because it is a min heap, and by this we can act like max heap. And then kf is equal to k minus 1. Wait a minute. We keep on pushing. So what do we have? At the end we have max number. At the start we have minimum number. Right. So k is smallest. So if length of is equal to k minus 1 while f is greater than 0. F is greater, k minus 1 is greater than 0. That is while k is greater than 1. No, k is fixed. So let's say k is 2. So what the hell is this code, man? Confusing. F is equal to k minus 1. Second element लिखा है तो first element. Okay. While f is greater than 0. What will I do? Heap q dot heap pop priority q. Remove an element. Reduce it by 1. Okay, so how many number of k is there? I'll keep on cutting the q from the end. Heap pop will remove the largest element, right? Yeah, heap pop will remove the largest element. So it removed the largest element. And why am I doing this exactly? For kth largest, bro, what? Question was smallest, no? Kth smallest element in an array. And what has bro told us? Okay. Kth smallest starts from here. Fuck you. Minute for kth smallest, no? What are we returning the last element? How are we returning the first element, man? Log in to build the heap. What have they told? n plus k log n. Let's say we have to find third largest, and the elements are 3. Okay, these are the elements. We have to find the third largest. What is this bro doing? For in range and doing k is equal to 3, f is equal to 2 while f is greater than 0. तो एक बार करेगा, फिर 2 1 होगा, फिर 2 बार करेगा, 2 रहेगा ना. Heap of ones becomes 1 is greater heap of twice. Okay, so whatever it is, it will do one less time, so I'm popping out 2 times. Okay, heap of will remove the smallest element, so I push 3 in a queue. Is this doing pop after? Okay, so pushed everything in queue and then afterwards I pop twice, so elements will be first pop 3 will go, second pop 4 will go, third peak will be 7. But isn't 7 on the last position? Bruh. Oh, it's on first position. What? Okay. Then what about get largest? Off and time to convert this into a valid min heap. Okay, it takes off and time. Heat.ep for array for underscore k minus 1 k log n. Time complexity is k log n. Accessing the root. Okay. Oh, this is heap pop, bro, not pop. Dang. What will happen with max heap? Whatever. Array of 0. 1 is x for x. So this is kth largest now. Heap.epify array. So the biggest will come on root this time, and then we'll go on popping for n number of times, k number of times. k minus 1 number of times. K log n. Okay, just when you get back. Then shall I try quick select? No, I'll try quick select at the end. Yes. This quick select. Alright, moving forward. Sort key sorted array. We did to sort array. What is this? Is this the same question? Not. Given two arrays, R1 and the elements of array 2 are distinct and all elements of array are also array 1. Okay, sort the elements of array 1 such that the relative ordering of the items in array 1 are the same as in array 2. Elements that do not appear in array 2 should be placed at the end of array 1 in ascending order. Array 1 is mix of all this. Array 2 में 2 1 4 3 9 6. So 2 1 4 3 3 9 9 6. And then comes song. All elements in array 2 are distinct. And array 2, we don't care about anything here. We are do sorting array 3 2 1 4 3 9 6. First I'll be placing all 2's, then I'll see 1 is there, 1 will be there, I'll place 1. 4, I'll see how many 4's are there, place 4. 3, I'll see how many 3's are there, it's 3. Then I'll see how many 9's are there. So what I can do is I can make a dictionary of first. Let me type dict. No. The word num count. Num count is equal to this, and then for num in num count num in array 1, num count of num plus equal to what is 1 plus num count would get num, if nothing then 0. We'll make a num count array. Okay, then in this for num in array 2, if num not in, if num in num count, the number is in num count, then I'll do answer development. I'll make an answer development num for I in range. Open key extend. Insert dot extend num array multiply by num count of num. Else rest and in the end I'll do answer. What have I written, man? Where did 7 and 19 come from? Wait, we don't need to take the if num in array 2 for num in array 2 अच्छा device num in array 1 क्या लॉजिक है भाई डमैस What was I thinking about? I made an M count of everyone in array 1 and then some of them might be 2 times 3 times. If num in num count, if num in array 1 thinking at आज कुछ हो ही नहीं रहा है मेरे से. Okay, fresh mind. So we know that everything in array 2 is in array 1. So what we need to do is we need the same order as array 2. So for nums in array 2, what do we do? Then if num is in num count, if that number is in num count and num count is made of array 1, right? If number is in num count, then I'll do numbers in order to. Why do you need this? How do I find the rest who are not present? Do I do array 1 minus array 2? No. Everyone whose count is equal to if I put many elements in the same array, would it increase the size? Oh, should be placed in ascending order. Relative sort array. Six, 9, and then 9, 6, and then 7 and 19. So whatever is in the rest, when does it come in the rest? If it is in array 2, if not in array 2, if not in array 2, then I'll do rest dot append. No, otherwise, if it is in array 2, then is 2 in array 2? Yes. Then how many times was it? 3 times. Okay, I'll put it 3 times. Then is 3. Okay, they can be dispersed and we have to put them in place. Then is 1 in array 2? Yes, it will be. So all these elements multiplied by whatever their count was. Phenomena array 2. And straight away do answer.extend num into count of nums. This will make the this much. Okay. Now tell me, how do I find 7 and 9 not present? Shall I run another loop? Let's see the first test, what they have done. Made a counter of array 1 elements, that is the same thing I did. Okay, and for element in array 2, element into this is the same exact thing, and then they are deleting. Oh, then they're deleting, so whatever is remaining, so whatever is left, that will obviously be this 9 and 16 in the array1 map. So for elements in array1 map keys, remember this out element, and then I'll sort it for element and element output. Return item for sublist in output for item in sublist. Bro, what? In output for item in sublist. Bruh. Item for, so output is getting appended correctly. Why has he written this thing, man? What happened is sublist. So the only change that they did here was deleting the num count, delete this key. Wait, how do they do it? Num counts dot element. And then for number in array, no, don't even need this. For number in num count, raise dot append. Similarly, whatever the number is multiplied by num count of that number. Append भाई, append. Extend. Oh, append भी होता है क्या ऐसे? Wrong answer. What happened? Expected. Ding 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 ding. 242 380 13 12 गायब ही हो गया. Why was 12 not left here? Oh, 12 is here. अच्छा, मेरे में से 12 ही गायब हो गया. How, man? Wait, is it same output or a map is counter of for nominary 2 for element in array 2 output dot append element multiplied by array map append. It works like this. Dumbass. Everything was correct, man. Just that. Yeah, this way we save some time complexity. Alright. What was this funny question? Back to heaps, man. We're doing everything except heaps. Merge and sorted list. It's a hard problem. You solved it. Clearly don't remember anything. Control X. Yeah. Merge k sorted list. You are given an array of k linked list. Each linked list is sorted in ascending order. Merge all linked lists into one sorted linked list and return it. 1 4 5 1 3 4 2 5. So I have to return 1 1 2 3. So linked list. So in order to merge, list of i's in sorted order. Okay, that's helpful. So what I have to do? So as they said that it is in sorted order, that means this will come before this, of course, and this. So first I will take minimum from this, this and this, that is 1. Okay. Then I will take minimum from this, this and this. Okay. That is 1. Then I will take minimum from 3, 4, 2. That is 2. 1, 1, 2, 0. Then I will take from what? This, this and 6, 3. Then I will take from 4, 4, 6. 4 will come, okay? Goes to 5. So 5, 4 and 6. 4. But at any point if it reaches to the end, then what? If linked list dot next is equal to none, तो फिर don't care. Otherwise, there is this, and then there is this. So I have to go on till my minimum element that I'm finding from is not empty. That is, my heap is not empty, right? So, and also, what is the length of lists? K is equal to length of lists. What is K? K linked list. So that means 1, 2, 3. That means my mini size will be K every time, right? Okay. List is sorted in ascending order. Okay, now let's solve this. So I want this min heap of length. Min heap is equal to, this will be my length, and list I can be negative also. Okay. Min heap is this. So what I'll do is, for linked list in but how do I get the element from linked list, man? For linked list in lists, for linked list and lists. Min heap dot heap q dot heap push, heap q dot heap push into min heap. What will I push? I will push ll. Okay, I pushed ll, and so this will be of 3, right? And then we will start. Let's start while my heap. So while I have any element in my heap, what will I do? I will first pop heap q dot heap pop from in heap. Okay, I'll get some element and get linked list. Then I'll take value and I'll put that value in answer directly. Answer is a list, no? Answer is equal to list. Answer append handle dot val. And one more thing. Once I pop this, I have to push something. I'll take when do I append? I'll append only if ll dot next. Also while pushing, I'll have to check if linked list dot val is there or not. What if I push something empty? So here for length of linked list, okay, this one, for length of linked list there is one element. So for L1 I'll push LL, but then when I push LL I'll do heap pop from that and I'll get empty LL. So if LL, what if I end up pushing? I don't have to push none values. If linked list, how do I check if it is not none? Dot if is not none, then only I'll push it into linked list. Okay, so this is to make sure that our heap never has a null value. So after I remove linked list, it is obviously not null. If ll dot next, if ll dot next is not none, then if ll is not none, then I'll do heap q dot heap push ll dot next. Also only then I'll add the value to my answer. Okay, one more thing. If it is not none, answer dot append and ll dot next, and ll is equal to wait a minute, क्या कर रहा हूँ भाई? I push into main heap, I remove that element, I remove the element, minimum, ये minimum है पक्का, so that I have to push to answer. And what is next for that? That I'll push back to heap. Yeah, that's it. Whatever written, man. Okay, can't push this, so yeah, I'll have to push the value first. Alright, ll dot val, but if two values are same, then what? Then I will I'll also use index, because index will be different, right, for both. For element list, yeah, for index comma linked list in enumerate list, I'll push value index and then ll, and then remember while popping out, first is value, second is index, third is ll, and what I'm pushing, value, and what I'm pushing back now, the same things, ll dot next dot val idx plus 1 this time. Okay, so hopefully this will make it. Who was never closed? He was never closed. Expected 2 arguments, got 1. Yeah, heap q dot heap push and heap. Oh my god, index plus 1. But how is this given? Whenever I remove element, this is 1, this is 2, this is 3, and this was done, this was minimum. So anyway, this and this, no, any one of them is minimum, right? But this is 1, this is 2, 3. So I need to do something that can give each element a different value, right? Index list, so first list into for every linked list, I multiply one element by 2, second element by 3, like that. There was one trick I remember in order to give unique ID to all the elements. It will sort this error. What was it? What was it? Value multiplied by something. What your index is on, value is on. Index multiplied by value. It doesn't matter. Index multiplied by val or something. Let's run this. Note valid value for experiment return tabulation node 1134 11234 1 1 2 3 4 where okay, I give up. Let's see the answer. Answer is right here. Oh shit, where is the answer? Well, submissions March 16th. Yeah, heap q dot heap by heap, index element list, heap q alert value index list. Yeah, this is right. Head is equal to list node minus 1. Okay, dummy head while heap. Yeah, dummy node next. What are we doing to the index? Keeping the index as it is, dumbass. How does that matter if I run this? Huh? Now was this accepted? What's the difference here? What's the difference? If L if next, if L is mini heap, value index and linked list, value index linked list, enumerate list, head is equal to return head dot next. Oh, not to return an answer, bro. You're supposed to return a linked list. How to make a linked list? List node of -1. Answer dot append nahi. Answer dot next is equal to LL, and then I'll return answer dot next. I'll preserve the head somewhere. So this will again give me that error, and multiply this by value to get a unique ID. This should output is 4 5. Brain doesn't work. It is equal to list node comma none. Dummy head while heap value index node is equal to heap q dot heap of heap, while heap value index node is equal to heap q dot heap of heap, and then dummy dot next is equal to node if node. Dummy dot next is equal to node because we know into heap node dot next dot val node dot next dot val idx and node dot next dot val idx and node dot next. What else did this guy do? Dummy is equal to node. Increase the dummy. What is dummy? Dummy's answer. What is being wrong here, man? How do they create a unique ID? Let's check. But IDX for loop doesn't update the loop body. You should use the index pop from the heap when pushing new. You should use the index pop from the heap when back into the heap. Use the correct index, not the IDX. Holy shit, man. Great. Bruh. Struggling there a bit. Replace each array element by its corresponding rank. Wow. Let's go and find some random problem again. Bro, what? Three, 2, 3, 1, 2, 1. Oh, dang. Okay. Random question. So whenever for a comma b in this list, wherever we find a, that will change to 3. So length of nums n comma m is 10 raised to 5. What is m? M operations to this array. Okay. All values of nums are distinct. All values of nums are distinct. This is surely something we know. And then operation length is equal to 2. Operation length is equal to 2, and this is 10 raised to 6. operation I comma 0 will exist in nums when applying ith operation. So 1. Oh, this is something I didn't observe first. No. What they say? Operation I comma 0. Operation of I0 will exist in nums when applying the ith operation. Operation I comma 0, that is when I is 1. What they say is operation I comma 0 when applying the ith operation. So second operation 0 1 2 while applying the what will exist in nums when applying the ith operation. So I'm applying 0 first. I'm applying second operation. Ith operation I is 2. I comma 0. While applying for second operation, I comma 0 will be in nums when applying the ith operation. Operation 2, let's see this. Okay, 0 1 2 2 comma 0 will be in nums, 6 will be in nums while applying the ith operation. It will be in nums while applying the ith operation. What do you mean, bro? What the fuck? This was nothing. Operation I comma 1 will not exist in nums when applying the ith operation. So at the end everything will be unique. Okay, got it. Back to question. Brain is working on 1 power, 1% capacity. Okay, so 1. Is it an extending or always? Have they given anything like that? They have not written anything like that. So what we'll do, we'll take 1, replace it by 3. How the fuck do I do this? Let's go by brute force. For A comma B in operations, nums of, I gotta remember this thing now. Or we can make a dictionary. It's a brute force approach. Index dict is equal to index dict of I is equal to I. Bruh. My key is value actually. So now how do I change it? Highlighted over all the values. Now let's reverse it for a bit. Index strict of none. So whatever was 1, I'll make it 3 now. I'll steal its value. She's real index. This, and I'll delete that key. And then I'll do index dict of num, index dict of b, a is equal to end. Wow, that's the math. So now I have all the numbers again with their indexes. What do I then do? Answer is equal to 0 0 0 multiplied by len of nums. Answer for LE in index dict for key in index dict, keys element in index dict. Answer of LE answer of index dict of LE is equal to LE. Just a sad song with nothing to say. Who is num? A. Okay, space complexity is bad. Let's go to this guy's code. See what he has done for the fastest solution, for the least memory uses. So what he did is replacements is a dictionary and then result for start comma end in reversed operations. What is reversed operations? 6, 1 6 start end 1. Replacements of 6 will be replacements dot get of op end is equal to that is op end. Okay, chain structure. So his replacements, they have why reversed though? Who cares about reversed? When did this say this is in increasing order? Return replacements dot get number for num in nums. For num in nums. Returning answer in place. Back to heaps. Anyways, I'm bored now. That's it for today.